Hello, Algebra 2, and here we are looking at section 5.3, that's quadratic, that curved parabola shape looking thing is kind of what we're looking at. It looks like a happy face, or however you want to call it. Okay, so what do we got going on today? We're doing some factoring and a little bit of graphing in there too, but the zeros, the roots, the root, we got a lot of that going on. That word's like all over the place. What does that mean? What that really means is, let's say we got a graph, like this or something. And the pieces that we're talking about are these pieces right here and right here. Those x-intercepts. So that's like another word that kind of means the same thing. So when you're talking polynomials especially, but quadratics for now, zeros are roots are x-intercepts. Horizontal axis intercepts. Sometimes you don't use x and y, you use other things. But that's the idea. Cool. Let's use that idea. So here we go. This first one, it says, find the zeros for each function by factoring. So factoring, the idea of factoring is trying to take these terms that are written with plus and minus and turn it into other terms that are just multiplying. And so let's see a couple of strategies here. This first one, I noticed that I can pull out some things that are in common. First, I have a 4 there, 24 there, and 24 is really 4 times 6. So I'm going to take that 4 and that 4 out, and then that's here. And that's what they're doing here. They pulled out this 4x. And then the next thing, we see x squared, which is really x times x, and this is just times x, and we see that there's an x in common. Okay, so they're going to pull that out too. So what's left over? 4x times x gives us the x squared, but what would the other one be? 4x times what equals 24x? That would be 6. Okay, so now we have two factors, and it's not really common to see this single term factor in parentheses, but I think it's just as good and deserving. So it gets parentheses too. Then what we would do is set each of these groupings here equal to 0. Why? Because if I know something times something equals 0, then by this thing called zero product property, which means just two numbers multiplied to 0, or multiple numbers multiplied to 0, then at least one of them is 0. So we could say, well, this one equals 0, or x minus 6 equals 0. Now we've got a couple of equations. Finishing them out, well, if I divide by 4, 0 divided by 4 is 0, so x equals 0, or x minus 6 equals 0. So x minus 6 equals 0, we would add 6, and you would come up with x equals 6. So these are your roots. Check. That was cool. All right, now let's try this one. Okay, now we got this crazy thing happening. There's a lot of ways you can look at. I'm going to go ahead and draw myself a box here. And this box is going to represent these pieces there. So I'm going to have an x squared up in the top. I'm going to have a 3 down here. And between these other two groups, it's going to multiply to 3 and add up to the 4x. Okay, so what does that mean? Well, let's see. That means that if I have x plus something here and x plus something here, those two numbers are going to add up to 4x. So I think that's 1 and 3. And here's what really happens. This becomes a 3x because 3 times x is 3x. And this becomes a 1x. And what did I just do now? I figured out numbers that multiply to 3, but then add up to 4. And it creates this kind of box type shape. And we actually kind of have a couple of methods. Some people call this like diamond factoring. What multiplies to 3 but adds up to 4, well, 1 and 3 do. And then that's a positive 1 and a positive 3 because this is positive 4 and positive 3. So this is what we multiply to, and this is what we add to. Cool? So that means we got x plus 1, x plus 3. Booyah. So that means x plus 1 equals 0, x plus 3 equals 0. Now we got to finish solving it. We subtract 1 from each side, subtract 3 from each side. We're kind of doing the same thing all the way through here. x equals -1 or x equals -3. That's the general idea. Let's keep this going. So now I have this number -5 and this number 4. I need to add up to -5 and I need to multiply to 4. Now think about this. I'm going to multiply to get a positive number, but I'm going to add up to get a negative number. The only way to do that is if I have two negative numbers. Okay, so what two numbers would this be? I think 1 and 4 would work. Yeah, it would, because -1 combined with -4 does make -5, and -1 times -4 makes 4. So that tells me that I would split this up like this. So I'm going to have x minus 1 times x minus 4 equals 0. All right, now where do I go with that? Well, I could set each one equal to 0. X minus 1 equals 0. X minus 4 equals 0. We add 4. We add 1. And we got all this going on at the same time. And we get x equals 0 plus 1 is 1. X equals 0 plus 4 is 4. Check. Now, the last one. This is actually a lot more like the first one, where you just have two terms, nothing in that third term. So when we're trying to factor this one, it's still going to have like two things multiplied. But we can just look at common pieces. I see this 3, and I try to think of the 12. Can a 3 come out of that? It can, sure can, because that's 3 times 4. So I'm going to pull out a 3. I'm also going to pull out an x. And 3x times something is 3x squared. That'd be 3x times x. And then 3x times another thing is 12x, and that would be 4. So now I got my two terms there. So 3x equals 0, or x plus 4 equals 0. So 3x equals 0, I would divide by 3. I got x equals 0. Okay, that was easy. X equals, what would it equal here? Well, if I subtract 4, x equals -4. So there's my two answers. Cool, cool, cool. Super cool. All right, so that's just kind of demonstrating that process. But take a look at the notes again, just to kind of see like where we're even using this. We'll get more into using it on the graph as well in the practice. Now we got some crazy factoring, and really, this is following the same patterns we've seen before. So don't get too confused. Let's just take a look at them. First it says 4x squared equals 49. Now I want you to realize there's a couple ways to do this. So I'm going to do it completely different than what they did, and then I'll do it how they did as well. So if I have 4x squared equals 49, I could divide both sides by 4. Then I would have x squared equals 49 over 4. And if I were to square root this, check this out. X equals square root of 49 is 7, and square root of 4 is 2. Now the catch, here's the big catch. You ready? I'm not sure. Are you ready? Okay, here we are. The big catch is that when you take a square root of a number, it could have been the positive version of that or the negative. Because like -5 times -5, so -5 quantity squared is 25. So when you take the square root of 25, that's either -5 or +5. Either one of those work. That's why we had to do this. Okay, so that was that. Now let's go back and see what they did. All right, they got 4x squared minus 49 equals 0. What we're looking at then is we got an a squared minus a b squared. That's what they see. And how would I forget? Well, okay, something squared equals 4x squared. So I know x squared is there, but then I also have to put a number here. And this is actually a 2 because it's 2 squared is 4. The other one's a lot easier. 49 is really 7 squared. So that's easy. So we got, here's our a squared, and here's our b squared. And where do we go from there? Well, that means that's going to factor, because we know, based on the notes above, that a squared minus b squared is equal to a plus b times a minus b. Yeah, it just factors like that. It's cool. Super cool. And that kind of makes sense. So let's take a look at that. That means we're going to have 2x plus 7, because that's like our a plus b. And then we're going to have 2x minus 7. That's like our a minus b, and equals 0. Now, if I were to set each of these equal to 0, I'd have 2x plus 7 equals 0, 2x minus 7 equals 0, subtract 7, add 7, add 7. 2x equals negative 7, 2x equals positive 7. Hey, look at this. We're getting our plus or minus when we make 1s out of these 2's. There's a 1, there's a 1. X equals negative 7 over 2 or positive 7 over 2, like we did over here. So keep in mind, sometimes there's a faster way, but sometimes it also helps to see where those numbers come from in a different way too. All right, this one, we got x squared plus 16 equals 8x. First of all, it's easier to do this whole factor thing. Usually, it's easier to factor if it's factorable. When you make one side equal to 0, so that's what they're doing. They're taking this 8x, moving it over there, but when you move it over there, it's going to be negative 8x. So we got negative 8x. Now we just got to factor. I'm going to not follow their pattern. And let's just think about this. If you got to multiply to 16, but add up to negative 8, okay, so that means I got to have two negatives again. And they got to add up to negative 8, but multiply 16, that'd be negative 4 and negative 4. Oh, so then I would just have x minus 4 times x minus 4 equals 0. Now, this is kind of weird because you could have written it like that, or you could say x minus 4 squared equals 0. Either way, you're going to set x minus 4 equal to 0. And I could do x minus 4 equals 0 again, but it's redundant. I don't need to. So that means I would have x equals 4, and that's my only answer. That is so weird, though, because if you think about a parabola, I feel like it should cross twice. Well, what's happening is at 4, we have that point where it crosses, but that's actually also the vertex. So it's touching, just barely touching. It's like kissing the line right there. It's like, mwah, kiss, and then goes back. That's it. So it just touches the one time and goes right back up. Okay, so that's this video. We'll do another one with the practice versions as well. Watch it again if you need.